Now we're doing question 1 for the review for section 3-2, and we have to find the horizontal and vertical asymptotes. Well, -2 will take this denominator to 0, so we have a vertical asymptote at -2. And for the horizontal asymptote, we've got to look at the limit as x goes to plus or minus infinity of 2x over x plus 2. Well, the degree of the denominator is 1, so we'll multiply by 1 over x. All over 1 over x, that's another way to write 1, and the degree of each of these denominators is 1. So this equals the limit as x goes to plus or minus infinity of 2x over x all over x plus 2 over x. And will you agree, as x goes to plus or minus infinity, this term goes to 0. These divide out and become 1. These divide out and become 1, so we have 2 times 1 is 2 over 1, and that equals 2, doesn't it? So the horizontal asymptote is at y equals 2. So vertical asymptote at x equals -2. Horizontal asymptote at y equals 2. Now we're doing 1b, and again we have to find the horizontal and vertical asymptotes. And will you agree 0 will take that denominator to 0? So we've got a vertical asymptote at x equals 0. Now to find the horizontal asymptote, so we'll look at the limit as x goes to plus or minus infinity of x plus 5 over x squared, and we'll multiply by 1 in the form of 1 over x squared and 1 over x squared. And we always choose the degree to be in our denominators here corresponds to the degree of the denominator given. So now we're looking at the limit as x goes to plus or minus infinity of x over x squared plus 5 over x squared all over x squared over x squared. These divide out and we get 1. This quotient goes to 0, as does this, because although one of the x's will divide out, we'll still have an x in that denominator. And so what do we get? We get 0. So the horizontal asymptote is also y equals 0. And we're done. Well, now for question 2. And we have to find the limit as x goes to -2 from above of the quotient 2x plus 2 over the quantity x plus 2 squared. So let's do a little brief graph of that. And clearly we have a vertical asymptote at x equals -2. And we want to know the behavior of this graph as x gets increasingly closer to -2 from above. So this equals approximately, and the reason I wrote that is because we're going to there's no harm done if we let the numerator take on the x-coordinate and the numerator take on the value of -2. So 2 times -2 is -4 plus 2. -4 plus 2 is -2. Makes our work a little simpler. And that's why I put approximately, because x is never going to get there, but for the purposes of what we're doing, we can do that in the numerator. So we're just looking for behavior. We're not looking for a hard and fast value. Now, as x goes to -2 from above, will you agree we're going to hit -1.9, -1.99, and so on, and this difference is going to approach 0. So, and it's always going to be positive. So when you have a negative divided by a number that's a value that's approaching 0 in the denominator, this thing's blowing up in a negative direction. So that limit equals negative infinity. And we're done. Which, by the way, that doesn't exist, but we're going to leave it as negative infinity because it defines the direction and what it's approaching. You never get to infinity, but we'll leave it in that form.